So we're here in Tron, our Ocean One, and we're gonna go on a little trip, planning on going, see how far we can get on the charge. Going down to a mall about 150 miles away, turn around and go back, and then see how it goes.
We are going to measure how far can we get on a charge. We are driving at a speed of 71 indicated. That should be 70 actual miles per hour. We have put in a destination that is 152 miles away. We have driven for a little bit already. We're planning to stop there, stretch our legs a little bit, get back in the car and drive back home. Hopefully we'll make it all the way back home. So round trip should be 304 miles. I'm expecting we should be able to get further than that. If we have a little bit extra juice left in the battery, we'll keep on driving and make it home so that we have zero left. Oh, I guess a little bit more than that. Outside is 93 degrees. Inside we have 70. I have a little tracker on my own phone that is measuring the actual distance we're doing, because the odometer on the car is not 100% accurate. It normally shows too short of a distance. So right now it shows 26.6, 26.7 miles driven, while the GPS on my phone shows us that we have driven 27.94, so now 28 miles. So right now we are 1 mile short compared to, like the car shows 1 mile shorter than the actual distance driven. When we're done with the trip, we'll find out what the accuracy is of the odometer. I think it's 3%, but we'll measure that. We'll also measure how much electricity we're putting back into the car and get some numbers from that, including the price of the trip. We're now coming up on 100 miles driven per the GPS. We're still doing 70 miles an hour actual. It's 71, 72. We've got the cruise control set to 71. The car thinks we have only driven 96 miles. So it just showed that the odometer is not exactly accurate. We're still guesstimating 53. It's been between 54, 53, 54, 55. But right now 53% estimated charge at arrival at our halfway point. And we have now 69% left. We have now parked at our halfway destination. We have 53% left on the charge of the battery. The car believes that he drove 145.5 miles, but actually we drove 151 miles per the GPS, and we spent 2 hours and 21 minutes doing it. We drove 70 miles an hour all the way down, except for the last 2 miles was about 45 miles an hour. We're back in the car, still 53% left, and just a whole lot hotter in here. So now we got into a little bit of traffic, hurting our mojo a little bit. We're trying to do highway speed for this little test, but it's only supposed to be 4 minutes. We've been in for about a minute now. We've got 4 more minutes of traffic, and then we should be going back at normal speed. Anyhow, on our handy-dandy little GPS here, we now have 200 miles we've driven so far. We are at 40% state of charge. And on our odometer, that since last charge, or the whole trip, 191, let's call 192. So the car thinks that it drove 192 miles, even though we actually did drive 200. So the car is shorting itself with 8 miles. And I believe that is why 2.0 had removed the energy calculator from the odometer.
the one that otherwise told us how many kilowatt per mile we are using, that disappeared.
So we're looking at the 16%, and that's going to go down to 15. See that there's a yellow bar. Yellow bar is on, so that's the alert or warning. So 15%. And how many miles do we have to go? Still 28 miles, right? 27, 30 miles. Okay.
Yeah, so the 28 is until our exit.
Okay.
And 30 until home.
All right. Just want to see if it changes to anything special or different at 15.
Yeah.
Okay, 15. Didn't change anything, so that's cool. I'll be back at 10%, I guess, but there we go. So it goes back and fluctuates on the percentage we're arriving at, but we're looking at 6%. So here we are at 10%, and it's red. Okay. This is information right here, the stats. Stats. So we passed 302 miles at this point, right? We're working on 302 miles.
Yes.
Oh, just okay.
While the car thinks he only drove 290 miles.
Meanwhile, let's see that is 6%. Fun in the sun. Well, it's not fun in the sun. If it were sunny, maybe I would be a little bit less scared. All right, Tron.
What could possibly go wrong?
Listen. All right, Tron.
He can do it.
I don't know if he'll ever let us ride in him again. It remains to be seen. Is this 5% now?
Yes.
We have the little battery sign right there in yellow. And we will be then arriving with 3%.
We might have to take one more trip.
No.
Like, one more loop.
You're
Yes,
loopy. No. You are loopy. Okay, so what's the damage?
So we got 2% remaining, 316 miles driven. We do about almost 3.3 miles per percent. So in reality, we should have about 6.5 more miles remaining. So we should be able to get 222.5, so 322 miles estimated on a full charge. Car believes that he drove 304.3 miles. So the car is short about 12 miles for this distance.
That's a big difference.
We'll do the math and find out what kind of percentage. And now to the fun part and purpose of this trip. We have 316 actual miles driven, converted to kilometers, where 1 mile is 1.609 kilometers, ends up being 508 actual kilometers driven. We still have 2% remaining, and with our current consumption, that gives us at least 6 miles remaining, making a total range of at least 322 miles with today's efficiency, and that is at 70 miles an hour. So what can you do with 6 extra miles? Well, here's a little fun statistic. The average US shopper goes to the supermarket 1.6 times per week, and the median distance to the supermarket is 0.9 miles. Ends up being 6 trips or 6 times. So 3 trips to the supermarket. So approximately 2 weeks of going to the supermarket, doing 70 miles an hour each way. That's pretty good. Anyhow, continue on. We had 316 actual miles versus the odometer that said 304 miles. Doing a little bit of math, that ends up being 3.9% difference, so almost 4% difference. So if anybody is doing a range test, they should take that into consideration, that the odometer is not to be trusted. Verify your distance with a GPS or maybe mile markers or whatever. And our Ocean here has 22-inch rims. So it is the big wheels. It is supposed to be knowing that it has those wheels on, but it seems like all the cars are measuring it wrong. So just be aware. Well, it took us 17 hours and 17 minutes to charge back up from 2% to 100%. And we have a Wallbox level 2 charger, 240 volt, 32 amp. It's in the United States. In Europe, you should be able to do a little bit faster because there you have higher voltage and more phases in the houses. So you should be able to get, I think it's like something like 11 kilowatts charging. So almost half the time you should be able to get a full charge in, I guess, if you have a really good charger. Anyhow, with the 106 kilowatt hour usable battery, 98% used, we get to a consumption of 103.88 kilowatt used on this trip. The Wallbox delivered 119.67 kilowatts, and we needed 103.88 to refill the battery. So a little bit of math there ends up with a loss in charging of 13.19%. And a little Google search shows that the normal loss in charging is between 10 and 30%. So the Fisker Ocean is actually doing pretty good. And loss in charging is the cost of doing business. It is, you lose power from heat, like cables get a little bit warm. You lose power from just running the computer that is, supervising the charging process of the battery. You're losing power from, or energy from, running the fan and the pumps that are maintaining the temperature for the battery. And that's all kinds of stuff. So it is normal. And apparently here we lost 13.19%. And the cost of the electricity for this trip, round trip, 316 miles driven, cost me $14.75. I don't think that is too bad. And now to the efficiency of our Fisker Ocean 1 and some fun comparisons. We drove at 70 miles per hour, which is the same as 113 kilometers per hour. Vast majority of this was on the freeway, actual doing 70 miles per hour. I think there was about 2 miles from the freeway to the place where we stopped and stretched our legs a little bit and had a short break, and they had something to eat. And then we drove back. We hit a little bit of traffic on the way back, but that was not too long. And we drove past the house, stopped, and got a little follow me car to make sure I could make it home if I got too gutsy, and drove it down to 0, which I did not. Took it down to 2%. We made it home safe. But we probably had another 4 or 5 miles after leaving the freeway that was driven at 45 to 55 miles per hour. But overall, it was pretty much 70 miles per hour all the way. And it was daytime, no rain, so it was a nice day, but it was hot, as you probably saw in the video. So AC was going and was fully capable of making it comfortable in the cabin, even in Earth mode. Anyhow, on with the math. So our energy usage, 98%, turned out to be 103.88 kilowatts hours that we used out of our battery, drove 316 miles. They end up being 329 watt hour per mile. In kilometers, ends up being 204 watt hour per kilometers. And if you want to have it the other way, we end up with 3.04 miles per kilowatt hour, or 4.89 kilometers per kilowatt hour. So now the fun and interesting comparison. Fisker Ocean 1 Extreme compared to Tesla Model X Plaid and Model Y long range, and then the Range Rover Evoque. I chose the Evoque just because many people think that the Ocean 1 looks very similar to an Evoque. So I thought, well, an SUV. So here I'm trying to do a little apples to apples comparison. People often speak about the Fisker Ocean to be a competitor to the Model Y. I saw a nice review of a guy who liked the Fisker Ocean, and he said that he also had a Model Y, and he did not believe that a Model Y was any competitor to the Fisker Ocean because there were two different classes. He would rather compare to the Model X. The Model X is about 10 inches longer, but otherwise it is the exact same weight class. The Ocean 1 weighs about 100 pounds or a little bit more, 100 pounds and some change more than the Model X. So the Ocean 1 actually has disadvantage weight-wise. Length of a car does not really do much for you with regards to the drag. So the 10 inches longer Model X should not have any notable disadvantages for the X. However, the Model Y has a big advantage compared to both the X and the 1 because it's 1,000 pounds lighter. So it's like 20% lighter. We'll speak about the Evoque after this. But my comparison here, I want to compare the Ocean 1 and Extreme with the Model X Plaid. And if we look at the efficiency, and my source for both the Model X and the Model Y here is Out of Spec Review YouTube's. I'll add their link to those two videos in our comments below. But Ocean 1, 329 watt-hour per mile was the usage there, or efficiency, while the Model X Plaid got 331 watt-hour per mile. So Ocean 1 a little bit more efficient, but that can change from a day or a drive or whatever. So I would say that they are equal. They have the same energy consumption. So, and this is a 2024 Model X Plaid that Out of Spec Review tested. So it is the latest technology from Tesla's Model X and the Ocean 1/Extreme compared to that. If you compare to the Model Y, that is 20% lighter. Yes, of course, the Model Y is more efficient, 266 watt-hour per mile, but still does not get the same range as we got out of the Ocean 1. So I thought that was pretty interesting comparison. A lot of people say that the Ocean or the Fisker product does not compare anything to Tesla because it's not purpose built for that, and they got technology from Magna and it's not as good. But here it seems when you compare apples to apples, two almost identical weight cars, they do get the same watt-hour per mile. So not bad at all. Compared to the Range Rover Evoque, just to compare to an ICE car, the Evoque is a little bit more than 1,000 pounds lighter. The EPA numbers there, 26 miles per gallon on the highway. Do the math, 316 miles divided by 26 miles per gallon, we get 12.15 gallons used. In my neighborhood today, the price seems to be for premium gas, as this car uses, is $4.40 times the 12.15 gallons, end up being $53.46 for the same trip. So that's about 3.5 times more than it would cost, what it cost me to drive our Fisker Ocean from home down to a little outlet mall and then back again. And yeah, covered 316 miles. It cost us $15, but in a Evoque it would be $53. So quite a bit cheaper. I could have bought a pair of Converse shoes for that. But that's it. I think those pretty interesting comparisons.